we're going to continue with this 0.5 half business, okay? So could you write for me on the board the numbers from 0 to 10 going up by 0.5?
Okay.
So start at 0 at the top. Start with 0. Yeah, comma, small comma, comma, not full stop. Comma, yeah, and then 0.5. Yep. Next number.
This is taking hours.
Okay, so write the first few and then I'll write the rest for you, but you can say them. Yeah, this is actually pretty good.
Okay, now the rest of them while you are there. Now I'm actually really tired.
Okay, have a seat. Now, can you say the rest?
Say the rest.
So there's 0, 0.5, 1, 1.5, 2, 2.5. Your comma is a bit big here. What's next?
3.5.
No.
3. 3.5. Also, the point things are like stick together.
Yeah. Close. Okay, maybe we can.
Now 4.
4. Let's go for 4 here.
4.5.
5.
5. 5.5.
Next.
6. 6.5.
Yep. Next.
7. 7.5. And then 8. 8.5. 9. 9.5.
Yeah.
Now you're done.
One more. We'll say one more and then we can.
Okay, 10. 10.5.
We just did 10, okay? Everyone 10.5. Alright? Okay. So do you remember last time we're saying this kind of counting, okay, is going forwards by 0.5. Okay? Remember how normal counting was at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right?
Right.
That's going up by 1, yeah?
Yeah.
But this kind of counting is going up by 0.5. So this is plus 0.5, right? Plus 0.5. Plus 0.5. Does that make sense?
Yeah.
So if you go forward along this list, okay, you're plusing 0.5. Okay? And we were saying that if you were adding two numbers, right? So if you're adding two numbers like 1.5 plus 1.5, right? You start at 1.5 and then you move along this list until you move along 1.5 times. So you have 1, 2, so 0.5, 1, 1.5, okay? And then that'll give you the answer is 3. Yeah? So talk a little bit about that. Yeah? So I told you before how to add these two numbers up. Yeah? And so you haven't fully mastered it or even really understood it very well, but this is another chance for you to understand it again. Okay?
Okay.
So you start at 1.5, right? And you keep moving until you moved enough, right? So you know the answer is going to be on this side of 1.5, right? If we added 0.5, we just move it across 1, right? We get to 2, right? But we're not adding 0.5, we're adding 1.5. So we're going to move it another 1. That's when you add 1, right? That's not 1, it's 1.5. So we're going to move it 1 more to 3, and that's 1.5, okay? So if you start at 1.5 and you move it 3 spots, which corresponds to moving it up by 1.5, you get 3. Okay? So this might need you to know that 0.5 plus 0.5, right, is equal to 1. Yeah? You know that? And you know that 0.5 plus 0.5 plus 0.5 is equal to 1.5?
Okay.
Do you understand that? Do you?
A little bit.
Yeah, so how does this work? So what we really mean is we want to do 0.5 plus 0.5 first, right?
Yeah.
And then plus the result to 0.5. So this here is 1, right? We know that. Okay, because that's just moving this forward once, right? Yeah, so that's 1 plus 0.5. Yeah? And 1 plus 0.5 is 1.5. Right? Because that's just, you start at 1 and you move it forward by 0.5. Yeah? It's 1.5. Okay? So basically what this tells you is that if you want to add 1.5, right? The 1.5 is 0.5 3 times. Yeah? See that? That means we're starting at 1.5 and we're moving forward 3 spaces until 3, and that's why this is that. Right? So 0.5 plus itself, see there's 3 of them, right? You get 1.5. So, for example, if you had like 5.5 plus 1.5, right? So you think about that, okay? So one of the things that you should think about, considering what we're talking about, okay, is that to start at 5.5, okay? You think about that now. So you start at 5.5, right? So your answer to this is going to be bigger than 5.5. It's going to be somewhere down the list, okay? Somewhere forward, right? And how far forward is it, okay? It's going to be forward by 1.5, alright? And 1.5 is equal to 0.5 plus 0.5 plus 0.5. So it's going to go forward 3 times, okay? You start at 5.5, you go forward once, twice. Where would you go when you get to 3 times? So once gets to 6, right? Twice gets to 6.5. Where does the third one get to? No. Where's the next one on the list?
4.
Huh?
Next one.
Yeah, what's after 6.5?
6.5. 7.
Yeah. So even drawing the list in 3 separate lines is making it harder for you, okay? So that's the situation we're in. Alright? And if we move it up 3, we get to 7, okay? So then the answer to this is 7. Yeah? Okay. So I want to introduce a few more things. And it's just basically the same thing again, okay?
Okay.
Remember when we did minus?
Yeah.
So how do we think about minus? You remember? What if I said 7 minus 1.5?
1.5.
Yeah. Yeah, so you have to try to remember the principles, okay, not the actual answer, because you can't remember all the answers to all these questions. There's too many, okay? And if you did, it would be pointless because there's always other questions. So what do we do with minus, okay?
Okay.
We never did it with 0.5, okay? But we did do minus with other things, okay?
Okay.
So it's not necessarily the case that everyone has to be taught what to do with this, okay? So if you start with a 7, right? If we plus 1.5, it means we go forward, you know?
Okay.
Okay? If we're minus 1.5, you see what we're doing? But do you remember what we did with minus?
Minus.
Yeah.
Minus.
Yeah, what do we do with 5 minus 2? You know the answer to this, but
It's 3.
it's 3, but how do we get to 3? So you knowing it's 3 very quickly helps this not at all, okay? And that's the problem, okay? So if you understand it properly, it would actually help you with this a lot. But since you only memorize it's 3, it helps you with it not at all, okay?
Okay.
So how do you get to 3 from here?
3.
Yeah. Do you remember when we have a minus, like 5 minus 2, right? You start at 5, okay? So we're always starting at the left number, okay? That's our convention. That's what we decided was the rule, okay? We start at the left number, right? And then we move backwards by 2. See? Remember, so adding is going forwards, minusing is going backwards. So if you go back by 2, you get to 4, right? Is 1. And then you get, what's the next one? You move back by another 1.
Okay.
So you get to 3, right? So if you start at 5 and you move it back by 2, you get to 3. Yeah, so maths requires you to have proactive thinking, okay? You don't want to think about what's next. You're not waiting for me to tell you what's next, right? So you have 5, you move it back 2, you get to 3, right? So as long as we can define minus, and it's not even defined, but we still should have some idea of how to define it. We want to go backwards from 7, right? So we start at 7, yeah? And we want to go backwards. You understand that? So what I mean when I say do you understand that is next time I do minus, you have to be able to think by yourself, okay? That you're starting from there and going backwards. You understand? Yeah, so next time if I say minus and you don't think of that, then it means this time you didn't fully understand it, okay? Or if you like, you could say you just forgot it, but forgetting is a result of not understanding, okay? Okay, so we're clear if we're minusing, we start with 7, right? Yeah, and we're going backwards, right? How much do we go backwards? No, so we'll go backwards by what this number here is,
Oh,
right?
1.5. I thought you said that 7 right there.
Yeah.
7 right
Okay.
there. Okay.
So we want to go backwards by 1.5, right?
Right.
So usually that would be a problem, but we figured out how to go forwards by 1.5, right?
Mm-hmm.
So basically the same kind of thinking what tells us how to go backwards by 1.5. Alright?
Right.
So how do we go backwards by 1.5?
Backwards.
Yeah.
1.5.
Yeah, so we're starting at 7, remember?
Mm-hmm.
Okay. How do you go backwards 1.5?
1.5.
Yeah.
Don't know the half of it.
Yeah, but you can still try.
Okay.
Look how we went forward by 1.5, okay?
Okay.
So we went forward by 1.5 by going 0 0.5, 0 0.5, and then 0 0.5, right? So 3 times. Yeah? So can you see if you go backwards by 1.5, you're going 0 0.5, 0 0.5, 0 0.5 again.
Mm-hmm.
So how do you go backwards by 0 0.5?
2.5.
So what's 7 minus 0 0.5? No, so you've forgotten the thing I told you again, okay? Start at 7 and you go backwards, okay? So this 8 is forward, isn't it? Yes? Go backwards.
6.5.
Yeah, it's 6.5, yeah. But the way you say it doesn't make me think you understand it. Okay, 7 minus 0 0.5 is 6.5, yeah? That's going backwards once, yeah? Okay, so what's 7 minus 1.5?
Wow.
How many times backwards do you have to go?
1.
No. Okay, so it's at least 2 times. So tell me, you go to 7, where do you go from here? Tell me. You go forwards? You go forwards?
No.
Why not? The minus, you don't go forward, right?
Yeah.
If you start at 7 and you're minusing, you go backwards. Okay?
Okay.
So let's go backwards. Where can you go from backwards? I already told you to go to 6.5. Can you keep going backwards? So if it goes to 5, that's gone quite a bit backwards. Why would you go so far? Why would you not say any of the ones in between? So if you go backwards to 6.5, what's the next one you go back to? keep going backwards from 6.5? What's the one before 6.5?
It's just a little bit
Yeah, I think you're underestimating yourself a little bit. This is not too hard for you because you don't really know what I'm expecting anyway. Okay?
okay.
Does that make sense?
Yeah.
So I'm not expecting you to get it right. I'm just expecting you to answer my questions, and you have to actually try. Okay? So if you're answering them all really easily, then it's actually too easy for you. You understand? There's not really a point where it's like, oh, this is just right. I mean, we have to get to this level, and there's some interesting questions to ask you, and you have to try to answer them. Okay?
Okay.
So, and then when you say yes and you understand, don't give false information. Okay?
Okay.
If you don't understand, just wait. Look, 7 goes backwards once, goes to 6.5, right? So if you understand that, there's no way you don't understand that the 6.5 goes backwards one more time to what? What's the next thing it goes back to? What's the number before 6.5 on the list? What's the one before that? Yeah. What comes before 6.5?
6.
It's 6. Okay? That's all going backwards is. Yeah? What's the one that comes before 6?
Before 6.
Yeah.
5.5.
Yeah. See, you know that now. Okay? So that's why if you say 5, it's going to make me think that's weird. Okay? Because you skipped all those other ones. Right? So if you're going from 7, right, backwards, what do you get? What happens if you go from 7 backwards? What's the one before 7?
Before.
Yeah, what's before 7?
7. Actually, before is 6.5.
Yeah, okay. So the one right before 7 is 6.5.
Okay.
Okay? Yeah. Yeah, I mean, you're not necessarily the best judge of what's too hard for you. Okay, that's the problem. People kind of give up very easily. But if you persevere, actually, a lot of these things are pretty easy. You just have to understand what they mean. Okay?
Okay.
And if you string a lot of easy things together, okay, you get something very hard. Okay?
Okay.
But it's something that's very hard that you know how to do. Alright?
Alright.
Okay. So if you count backwards from 7, just count backwards from 7. What do you get? 7. What's the next thing backwards from 7? What's before 7?
Before is 6. 6.5.
Yeah, and then keep counting. What's the next one before 6.5?
Is 6.
And then?
5.5.
Then?
5.
Then?
4.5.
Yeah, then?
4.
So you understand it, right? So we're going backwards from 7. Alright? Okay. So we need to go backwards 1.5. Yeah? So when you get to 6, that's 0.5. Okay?
Okay.
And we're saying that 1.5 happens when you do 0.5 3 times. Okay? So you just have to count backwards from 7 3 times.
Okay.
Okay? So let's do it. So 7, 1 time is 6.5, right?
Alright.
2 times is... So you lost focus for a second. You don't understand what I'm doing again. Yeah? How do you count backwards from 7 3 times?
3 times. It's just counting backwards by half.
Yeah.
So
Yeah, so you got it, right? So 3 times, if you do it 3 times, you get 1.5, right?
Yeah.
So that'll give you 5.5, yeah?
Yeah.
Okay. And notice, okay, that this is just undoing all the forward counts of this, right? So if you count forward by 1.5 from 5.5, you get to 7, right? That actually means that if you count backwards from 7 by 1.5, you get 5.5, okay?
Okay.
So this answer is actually equivalent to this already here, okay? They're the same.
Okay.
So you don't actually have to get this by itself. You can actually just look at this and say that this is true. You understand?
Yeah.
Yeah. Okay. So yeah, I mean, in a 6-year-old, the logic is not that developed. So you can see that this going forward, okay, gives you 7, right? So that means 7 going backwards will give you that, right? They're the reverses of each other. Okay. Okay. So that's minus. Okay. I want to talk a little bit about. See, a lot of these things are pretty natural, right? So I wrote here. I wrote here 0.5 plus 0.5, right? Right? But what is that? Can you see how that's similar to something we've done before?
I think so.
Yeah, like I remember we did something like this before. What's that? What about this? We did this one definitely. Where did it come from? Okay? I don't need the answer. I just want to know where it came from.
Okay.
Yeah, it came from me. But what was that? That was not the question I wrote, was it? I didn't write that question. What was the actual question I wrote? Ah, yes, you remember, okay? So the actual thing I wrote was what? Oh, so what is times? You said times table. That's good. So what do I? So what's this? As times? No, no, no. I don't want the answer. Okay, I want the question. What was the question I asked you? You said the times table, right? So that's almost correct, but I don't know. I feel like I'm letting you off too easy if you just say some word and I tell you the answer. So how is this related to times tables? You said before, or you said last time. Remember last time you said when you're plussing, it's like timesing. Remember you said that. Do you remember saying that? So is this timesing?
I guess so.
What's timesing what?
It's times 7.
Ah, okay, that's good. So it's something timesing 7, right? Yeah.
Okay.
Alright, what's timesing 7?
Times 7 is the times table.
No. How do we know what number's timesing 7? Remember? Well, maybe this will jog your memory. What's 3 times 7? Or what's...
21.
Yeah, but that's not important, is it? It's not important that it's 21. Because we're not thinking about the answers to the problems, right? We're thinking about what it is. So what's 3 times 7? In terms of pluses. Yeah, I mean, you just have to like kind of focus your ideas in this train of thought that I've created for you. So this is not easy, okay? But it's something that has to be developed. Getting tired. We're almost done, so it's okay. We're almost done. We're a little bit over time. You're concentrating well. 3 times 7, okay?
Okay.
See, that's the problem. If you're trained to just say it's 21, okay, you'll end up getting an answer that's irrelevant to what we're trying to do, okay?
Okay.
Because what we're trying to do is we're trying to figure out this is how many times 7, right? So 3 times 7 is 7 plus 7. What is it? Plus 7, right? You understand that?
So there's 3 7, right?
There's 3 7s. Exactly.
Because times makes it 3 times 7. So when you say the 3 first, that means it makes 3 7.
It makes the 3 7s, yeah? Good, good. So what do we write here then?
Uh, 15.
No. Look, the question is how many 7s, isn't it? What do you write here?
3.
No. There's 3 7s here, yeah?
Yeah.
But how many 7s are here?
Must be 7 7, right?
7 7s, exactly. Okay? So that's what you write here. How many 7s there are, right? Yeah?
Oh, okay.
So I helped you through it a little bit, okay? But can you see your brain is just, it sometimes gets distracted, okay?
Okay.
Because you came back and you tried to say 53 again, okay? It doesn't actually matter. It's not 53, okay? But it doesn't actually matter what the answer is because we're not looking for that. That's it. Yeah?
Mm-hmm.
We're looking for a way to express it, okay? And you forgot about that, alright? Okay? But you were switched on when you got that there were 3 7s there, okay? But that was only after we had to take this idea of 21 out of your head, right? Sometimes it's good to know that 3 times 7 is 21, okay? But this was not the time. You understand? Okay. So, 7 times 7, 3 times 7, that just means that there's that many 7s, right? Okay. So, as you get older and maybe better at this, You'll also start wondering why I started talking about that in the first place, right? Why did I just suddenly start talking about 7 times 7, okay?
Okay.
And this is where your brain has to be active in seeking these answers, okay?
Okay.
You understand what I'm saying?
Mm-hmm.
So your brain needs to be alert, okay?
Okay.
At the moment, it's a bit overwhelmed with information. You don't know what to do, okay?
So
Eventually, you have to seek the answers to those questions and to ask those questions, okay?
okay.
Alright, it doesn't matter if you don't understand, I'm just going to keep saying it to you and it's recorded, you can watch this over and over again, okay? So, the reason it's what we're trying to do is this is what we have here, 0.5 plus 0.5 plus 0.5, right? Okay? So if we go along the same train of thought, okay, what would this be?
That
Yeah, so
is saying the 7 plus 7 plus 7 plus 7 plus 7 plus 7 plus 7 again is 6 sevens. I mean there's 7 sevens.
yeah, so however many sevens there are, you write here, right?
So
And then whatever the
seven.
number is in there, it's you write here.
There's 7 sevens.
That's 7 sevens. But what about this? How do you describe that in the same way? So instead of 7, what do you have?
7.
So is this similar to this?
I think so.
Okay, and how is it similar? Okay, so here is 7 being repeated, right? There's lots of 7s, yeah? Here, there's something being repeated. Is there something being repeated?
No.
What do you mean, though? You can look at it. Is anything being repeated? What does repeated mean? So the word repeated means it happens again and again and again, right? So here there's 7, 7, 7, 7. So 7 is being repeated.
Oh, when you say the word repeat, I still remember that I remember the repeat on the laptop.
Yeah, but if you don't know what a word means, you can ask, okay?
Okay.
But sometimes you can figure it out too, but like, you can't just ignore it and not understand what it means, okay? So repeating means it comes up again and again and again, right? So that's 7 does that, right? Does anything happen again and again up the top? Here, is anything repeated?
Repeated. Yeah.
What?
It's the repeated thing is the 1.5 and the 2.5. So 1.5 it starts from 1.5 and then it goes another 1.5. So that's repeated, right?
So you're saying that's repeated, yeah?
Yeah.
Is there anything here that's repeated?
Yeah. Because
What?
the 0. There's 0.5 that is there, and then it repeats 2 more times, like over 0.5,
Yeah.
0.5.
Okay, so can you see the thing that's being repeated is the second number when you times it, right?
Yeah. The times is a repeat thing, right?
Yeah. So can you see how this would be related to timesing then?
Timesing, yeah.
How? Yes, we can see that it could be related, but we don't know exactly how, yeah? That's perfectly normal, fine response. That's actually a pretty accurate response. It's better than just anything either extreme of that, which will mostly be not true. Okay. So the repeated thing goes here, right? You see that?
Yeah.
That's something times 0.5. Yeah? Just like how the other thing was something times 7. Right? And what times is 0.5? You said something, but you didn't finish saying it.
What?
What did you say?
What I
So what should go here? What number goes here? We talked about that, right?
said.
So this is where understanding is different than just rote learning, okay?
Yeah.
You finish this, we're almost finished, so just hang on there. Hang in there. Do you understand what we're doing? You've forgotten. We're trying to write this as a times. Yes?
Yeah.
So how many times 0.5 is that?
And
So here it's 7 times 7, right? Because there's 7 sevens. There's 3 times 7 there because there's 3 sevens. Okay? How many 0.5s is that?
3.
There's 3. So what should I write on the right there?
3.
3, yeah? So this is 3 times 0.5, okay?
Okay.
Yeah?
Yeah.
And remember how we said this is 1.5, right? So we have that 3 times 0.5 is equal to 1.5. Yeah? Okay? You understand that?
Not really.
So we have, so you understand that this is equal to this, yeah?
Yeah.
And you remember we also said that this was equal to this, yeah? So then they're equal to each other.
Oh, so that's 1.5. You're saying 7 times 7 is equal to 1.5.
No, 7 times 7 is equal to 49. It's something else, yes?
Okay.
But importantly for this, 7 times 7 is equal to 7 plus 7 plus 7 plus 7 plus 7. So that means this plus this plus this is equal to 3 times 0.5.
Right.
So basically what we're doing is we now have a way to times some of the numbers we just learned, okay?
Okay.
So we can times 0.5 by 3, okay?
Okay.
We can times 0.5 by 2. That's what that is, right? You understand? No, you're very slow, but it's okay.
One more time, and maybe I can understand this one.
Yeah. So this is the last thing to understand, and then we do some exercises. So we have 0.5 plus 0.5 plus 0.5. What's that? No, it's not actually. So the time you're actually spending thinking it's hard, you actually could be trying to solve the problem, okay?
Okay.
So this is an attitude problem, alright?
Right.
Yeah, this is hard for everyone, do you understand? And that's why we learn it. Okay? If it was easy, we wouldn't start, but we would just wait till everyone's 18 and then start teaching them, okay? We wouldn't have to deal with all this 6-year-olds trying to learn maths, okay? The reason we learn maths is because it actually can be taught very well from 9 years old, okay?
Okay.
Some things can be gained from before 9 years old, right? And it's actually hard, okay?
Okay.
So people want to get an early start on it. You don't want to be learning. You don't want to be struggling with this when you're 18. Yeah. So when you say this is a little bit hard, it's actually just an attitude problem. Okay. Okay. So there's two things you could think about here based on what we said. All right.
Right.
Two things. Okay. The thing I would expect you to think of, just because we said it so recently, okay, is times. Okay. So even though it doesn't give you the answer, it doesn't give you one number, it tells me that you know how it's related to time. Okay? So what's being repeated here?
Repeated.
Yeah. Yeah, the 0.5 is repeated, okay?
Okay.
How many times is it there?
4.
4. Okay? So if I want to express this as time, what is it?
Time.
Yeah.
But what time? You know what time?
Yeah, what does times mean?
That time what it means. Times let you just make you like more clever of like maths because times can repeat when it repeat you get better and better, right?
Yes, I mean, it gives you another way to express this, okay? So I don't think you really understand what I'm saying, but look, you said that there was 4 of them, that was 0.5, right?
Yeah.
So what that is, it's 4 times 0.5,
Okay.
right?
Right.
That makes sense, right?
Yeah.
Now, you really have to appreciate these things. You can't just like, yeah, and move on to the next thing, okay? Because there's an idea here that you have to understand, right?
Right.
So I would expect some people to be like, oh, it's 4 times 0.5, okay?
Okay.
You know what I'm saying?
Mm.
Because that's how it's related to that, isn't it? Yeah. Okay, so that's one thing that's interesting, okay?
Okay.
We can express it as 4 times 0.5, okay? The other thing that's interesting, okay, is if we're going up by 0.5, that's just counting, right? We said that at the start, so this is something you've probably forgotten already, okay? But if you start at 0.5, okay, you have to go 1, 2, 3, right? Yes? So you start at 0.5, you go 1, 2, 3. Where do you end up? At 2, yeah? So we now have two things. We have that this is equal to 2, and that this is equal to 4 times 0.5, okay? So we not only get that these things are true, we also get that 4 times 0.5 is equal to 2, right?
So then you just draw a 0.5, right?
Yeah.
And also that's a shorter way to give the answer, right?
Yeah, I mean, all these things, if you know one of these things, right? So this thing might be the thing that you don't know, but you know what this is, then you can use this equals that to get the answer, right?
Right.
Okay. So I think you have enough of an introduction, okay,
Okay.
to work through the problems, okay, but you don't fully understand this. Yeah? So, but you can understand it. Can you see, like you said, it's a little hard for you, right?
Mm-hmm.
But whatever that little hard for you was, okay, getting to here would have been too easy for you. Does that make sense? So from little hard to you to too easy for you is basically this step. You understand? So once you can think for yourself, okay, how to get from here to here, right? Right? Then that's you moving from what you think is a little hard for you, right? To something that's easy for you. Okay? Because in maths, if you know it, it's easy. If you don't know it, it's impossible. Alright? Okay, so going from a little hard for you to easy for you is just coming up with the thoughts that link these two things together. Okay? So that's like coming up with the thoughts for why this is 3 times 0.5. Okay? Okay, so the exercise we're going to do now is going to be basically addition tables and some multiplication. Obviously, we can't multiply. We don't know how to multiply like half by half yet, but we do know how to multiply 4 by half. Okay? So we're going to do some of that after the break. Alright?